Hello, today I want to show you new technique in number theory. This is called Vieta Jumping. Now we will solve IMO 1988 problem 6. There we are given two positive integers ab and b such that ab plus 1 divides a square plus b square, and now we need to show that this number a square plus b square over ab plus 1 must be t square for some number t in positive integers. To prove this, now let's define s of k. There we need to insert all pairs such that a square plus b square over ab plus 1 equals k. And now let's discuss the pair with the minimal sum such that a plus b is minimal. And we can also assume that a is more or equal to b, and this is more than 0. So clearly if b is 0, we get that k equals a squared, and we will finish the problem. Now let's discuss this case. And instead of a, we can write x. So x squared plus b squared over xb plus 1 equals k. Now if we multiply both sides by xb plus 1, then we'll get that x squared plus b squared minus k times x times b minus k equals 0. And now we can look at this equation as a quadratic equation with unknown variable x, and now we will need to use the Vieta's formula for this one. If we know that x1 and x2 are roots of this equation, then x1 times x2 must be b squared minus k, and x1 plus x2 must be k times b. Now we know that a is one of the solutions, so let's assume that x1 equals a. And now we will see that x2 must be less than a. So if we found such solution, then we will get the contradiction that a and b are this pair with the minimal sum. What can we say about x2? x2 must be k times b minus x1. So this number must be integer. And from this equation, we get that x2 equals b squared minus k over a1 over x1. And clearly this equals b squared minus k over a. Now we know that b squared, k is not a square, so b squared minus k over a, this number must be less than a, because we know that k is a positive integer and a is more or equal to b. So we have seen that x2 is less than a. So we have found the more solution which has the less sum than a and b, but now we need to show that also x2 must be also positive integer. To show this one, we need to use the fact that b squared must be greater than k. And clearly this is correct, because otherwise we get the contradiction that b squared divided by ab plus 1 must be less than k. And now we can write that equation x2 squared plus minus k times b times x2, then plus b squared minus k. And for this one, this is clearly more than, if x2 is negative number, then we get that x2 squared plus k plus b squared minus k. Now I have used the fact that kb times x2 must be more than negative k, because x2 is negative number. So we get that this number is more than 0, and clearly this is impossible. So we have proved that x2 must be also positive, non-negative integer, and x2 is also less than a. So we have found a solution which is which has the minimal sum, less sum than a plus b. So we get the contradiction that a plus b was the pair with the minimal sum. So our assumption was wrong, and b square must be equal to k to get the number equal to 0. So in this case, we have seen that the only possible solution must be then a equals 0, and answer must be k must be b square if we discuss the minimal solutions. So we have proved that all the possible choices for a square plus b square over ab plus 1, then this is integer, this must be a perfect square. In most of the problems, there we need to use Vieta jumping. We need to discuss some quadratic in the quadratic equations. There we need to change one solution to another by using Vieta's formulas for product of the solutions and the sum of the solutions. So this was all I wanted to consider for today. If you want to discuss some theorems, please write in the comments.